Please subscribe to our channel for all our content. Now, on to the show. Yellowstone National Park, a wonderland of geysers, hot springs, and abundant wildlife. Beneath this picturesque landscape lies the Yellowstone supervolcano, capable of eruptions thousands of times larger than any in recorded history. Its geothermal features, like Old Faithful, are a testament to the immense heat below. This heat powers the park's features but also fuels the supervolcano. The park sits atop a massive caldera, a scar from a previous super eruption. Yellowstone is a place where we witness both the beauty and power of nature. What exactly is a supervolcano? It's not a volcano that's simply supersized, it's a volcano capable of eruptions dwarfing anything in human experience. Imagine an eruption ejecting over 240 cubic miles of material. That's enough to bury the entire state of California under a foot of ash. Supervolcanoes don't have the typical cone-shaped mountains we often associate with volcanoes. Instead, they form massive depressions called calderas, often so large they can only be recognized from space. These calderas form after a super eruption empties the volcano's magma chamber, causing the ground above to collapse inward. The sheer scale of a supervolcanic eruption is almost incomprehensible. The ash and gas ejected into the atmosphere can block out the sun, causing global temperatures to plummet. This volcanic winter can last for years, disrupting agriculture and ecosystems worldwide. Such events are thankfully rare. The last known super eruption on Earth occurred in Indonesia over 74,000 years ago. But the potential for another such event, particularly at Yellowstone, is a sobering reminder of the forces that shaped our planet and continue to influence our lives today. Yellowstone's history is a testament to its explosive power. Scientists have identified 3 major eruptions, each reshaping the landscape. The first, 2.1 million years ago, created the Huckleberry Ridge Tuff. The second, 1.3 million years ago, formed the Island Park caldera. The most recent, 630,000 years ago, formed the Yellowstone caldera. Yellowstone is an active geological system, constantly evolving. The frequency of eruptions leads to speculation about the next one. Section 4. The day the Earth trembles. Potential impacts of an eruption. The potential consequences of a Yellowstone super eruption are staggering. Imagine a scene straight out of a disaster movie, the ground trembling with the force of 1,000 earthquakes, a massive column of ash and rock shooting miles into the atmosphere, and pyroclastic flows, fast-moving currents of hot gas and volcanic matter, racing across the landscape, incinerating everything in their path. The immediate impact on the surrounding region would be catastrophic. The northwestern United States would be buried under feet of ash, destroying infrastructure, agriculture, and ecosystems. The ash cloud would spread across the continent, disrupting air travel and potentially triggering a global volcanic winter. The long-term effects would be equally devastating. The massive release of greenhouse gases and sulfur dioxide into the atmosphere would have a profound impact on global climate, potentially altering weather patterns and agricultural yields for years to come. The economic, social, and environmental consequences would be felt worldwide. It's important to remember that this is a worst-case scenario. Scientists believe that smaller eruptions are more likely in the near future, and they are constantly monitoring the volcano for any signs of increased activity. Section 5. Living with uncertainty, monitoring and preparedness. The reality is, we live in a world shaped by geological forces beyond our control. We cannot prevent a super eruption at Yellowstone, but we can mitigate its impacts through scientific monitoring and preparedness. The Yellowstone Volcano Observatory, a collaboration of government agencies and universities, keeps a watchful eye on the supervolcano 24/7. Using sophisticated instruments, they track ground deformation, seismic activity, gas emissions, and other indicators of volcanic unrest. This data helps scientists understand the inner workings of the volcano and provide timely warnings of potential hazards. While predicting the exact timing of eruptions remains a challenge, monitoring provides crucial information for emergency planning and response. Preparedness is key to minimizing the impact of any natural disaster, and a super eruption at Yellowstone is no exception. Developing comprehensive evacuation plans, stockpiling essential supplies, and educating the public about volcanic hazards are crucial steps in building resilience. Section 6. Conclusion. Respecting the power within. Yellowstone serves as a stark reminder of the awesome power that lies beneath our feet. It's a force capable of both creation and destruction, shaping our planet over millennia. While the thought of a super eruption is undoubtedly frightening, it's essential to approach this topic with a balance of caution and curiosity. We must respect the power of nature while also recognizing the importance of scientific understanding and preparedness. By studying Yellowstone, we gain valuable insights into the Earth's deep processes and the potential hazards they pose. Through monitoring, research, and public education, we can strive to live safely in a world where such powerful forces exist.